Sometimes the triangle can be ambiguous, i.e. undecided, or open to more than one interpretation. What do we mean by that? Let's see how a triangle can be ambiguous. Let's say we want to construct a triangle ABC with AB being 8 centimeters, BC 7 centimeters, and the angle BAC as 55. Before we do that, let's try a little sketch so that we appreciate what we're dealing with. So we draw a little sketch that is not to scale. Let's say that this is AB and this is the vertex C. This would be 8 centimeters. This would be 7 centimeters. And this angle is 55 degrees. So let's start. With a ruler, we draw a line that is 8 centimeters long. Then, with a compass, more or less, we mark an angle of 55 . And then we connect the side this way, and we don't know the length of this side, so we just extend it. So we have an angle of 55 and a base of 8 centimeters. Now, with the compass, we open at 7 centimeters. We fix the compass at this side, and then we draw an arc that is 7 centimeters long. We now connect. But the thing is, where do we connect? Because we have an issue now. Because this distance is 7 centimeters, and this distance is also 7 centimeters. So with this set of instructions, this being 8, this being 7, this being 55, we can draw two triangles. This angle here is definitely 55 degrees. This side is definitely 8 centimeters, but we have two options for the 7 centimeters, either here or here. So our triangle is possible in two different forms. The first form is this big triangle, and the other form is this tiny triangle here. So this is what we mean by an ambiguous case, where the information that we have in the question allows us to draw not one, but two triangles. So how do we deal with those problems with the sine rule? So in this case, let's just draw the sketch here. This is 55 degrees, this is 8 centimeters, and this is 7 centimeters. So what we do is when we solve, we take care that we know that this is an ambiguous case. So let's say we want to find this angle first, which is the only one that we can find. So A, B, and C. And let's use the form sine C over little c, because we want to find the angle C. So sine C divided by 8 is equal to sine 55 divided by 7. And this gives us sine C equals 8 sine 55 divided by 7. And let's work that out. Sine 55 divided by 7 equals, and we have the sine of the angle C, and we find the inverse sine, and that's 69. So we have to remember at this moment that C equals 69 degrees or 180 minus 69 degrees, which is 111. 1. Let's go back to the sketch here. When we constructed the triangle, this was A, B, and we had two potential points for C, either here or here. And if you look at this angle C, it's obtuse, whereas this little angle C is acute, and they both have the same sine. So when we did the calculations, we found that C can be either acute as 69 or obtuse as 111. So we remember that C can have two possible values. Now with those two possible values, you can work out two possible values of B, and with two possible values of B, you can work out two possible values of AC if you so wish. So when is a triangle ambiguous? A case is potentially ambiguous when there are only two known sides and an angle that is not included. Remember the problem here? We have two known sides only and an angle that is not included. Now this may remind you with the triangle in the previous video that we talked about when we introduced the sine rule. In this case, we did not mention that it was ambiguous at all. We proceeded by saying 12 divided by sine 78 equals 8 divided by sine, and let's call it theta in this case, and we found that sine theta equals 8 sine 78 divided by 12, and with the inverse sine, we found that it was, say, 41. So why didn't we say that it was 41 or something else? If you look at this triangle, is it possible to have an angle of 78 and an angle of 139? In that case, if you add the two angles up, they will add up to more than 180 degrees. So even though this triangle started out seemingly as a, at least potentially, ambiguous case, it really is not. So for you, I would like you to think of this challenge and determine when a case is ambiguous or not. At least when a case seems to be ambiguous, but it is not. Think about that.